Hi, so I'm Adam, one of the co-founders and CTO at Mux. Mux does a handful of things. You might know us, as previously mentioned, for being the organizers of Demuxed, which we'll touch on a little bit more at the end. We have a video streaming API where we handle kind of everything from ingestion of video out to delivery through CDNs, as well as our quality of experience data analysis tool, which is mostly what I'm going to focus on today. Before I get to that, actually, I've been on a journey ever since maybe the first version of ChatGPT came out, really trying to figure out how do we turn this into something that can kind of be my data analysis buddy, right? It seems like it's really powerful at looking through data in certain configurations. If you give it the right thing, you get some really interesting stuff out. But so far, it has been elusive to go all the way to like this is kind of the operational piece of piece of technology that we can actually use to operate things. I don't know if we're going to get there anytime soon, but this talk is a little bit more about a snapshot in time on that journey, as opposed to most of the other talks here. People have completed a project, so we're midway there. This is a snapshot, and we'll keep presenting on it. So the first thing first, you've got to get your data to the LLM to do some work. You can copy and paste, but this new protocol that's come out recently, the MCP protocol, is really nothing more than a special HTTP protocol, if you will, to hook up MCP or an AI agent to data sets. So we launched one of these a couple weeks ago, just kind of like every other SaaS provider out there. Really, it's nothing special, but a wrapper around our existing API. But you can use this today. It's a really nice, easy way to get started with playing with data and the APIs in your LLM. So hook it up. Quick drop in, it's easy, just kind of works out of the box. And what can you do with it? Well, first I will show one example from our video API. Here's my prompt up here. It says something like, ingest the following video, it's an MP4 hosted somewhere online, wait for it to be ready, enable some captions, wait till those captions are ready, download the captions, pull some thumbnails, and tell me about the video. This was like an experiment I did not think was going to work out of the box, but kind of in one shot in Claude Code, you can say, go from video file in, or not Claude Code, but the actual Claude desktop, go from video file in to an output that is, here's a description of every thumbnail, and a safety assessment. Is this safe for work content? So it's pretty cool, right out of the box, no kind of batteries included. You can build a kind of content ingestion and moderation workflow. One really interesting thing that happened along the way, kind of looking at what the LLM had done, at one point, it said, well, we're waiting for the captions to be produced. So in the meantime, why don't I start downloading the thumbnails? I just thought this was interesting. If you've ever written software, particularly like multi-threaded, software that, where you're kind of waiting for multiple things to be ready, the fact that this just kind of did this out of the box is pretty cool. Another thing that's really interesting is around building quick visualization. So on the data side, and you can't see the prompt there, but it's basically like grab the rebuffering data over the past week and help me visualize it. The Claude desktop can pull that data down using that MCP server, write some JavaScript, HTML code, and render it over here on the right. Really handy thing that just works today out of the box for visualizations. But where's the streaming specialist, right? You can ask it something like this, in 3 sentences or less, what's the best performing CDN in Poland? You can see it makes a tool fetch call, get the playback failure percentage from the CDN, the data's kind of hidden there, and then based on that output, it says, hey, the Mux CDN is the best CDN, and I've whited out the other names there. This is like a really interesting first step. We grab some data, we interpreted it, accurately, to at least to some degree, and we're able to present it back. But when you want to go beyond this, say a multi-step process that is looking at failure percentages, rebuffer rates, startup times, and try to tell that more complex story about what's actually going on and maybe what's the root cause, things get a little more complex and go off the rails. So that really becomes an orchestration problem. Like what we really want here is an agentic workflow that can like understand the scope, in this case, like the video, operations domain. It can create plans, it can navigate the data intelligently and accurately, while also iterating on that analysis, diving deeper as it needs to, and be cost effective and fast. More importantly, fast than cost effective, honestly, in this case. So I'm going to talk about a few challenges here of just like what goes wrong immediately. time is difficult. I think numbers in general maybe are difficult for LLMs out of the box, but time in particular, they don't like Unix timestamps. Our API today and the data that comes back from the LLM, if you look down here on the bottom left, is kind of Unix timestamps. This is a framework here called Brain Trust for being able to evaluate multiple LLMs and multiple prompts at the same time. And you see every single one of them got, although this was from July 10th, 2025, every single one of them got it horrifically wrong and wrong in its own unique way. So what's the quick fix? If there is one, this is kind of just a discovery along the way. Fun fact, if you switch from Unix timestamps to like the standard ISO timestamp, it kind of just works. It goes from 80% effective to 99% effective, or effective. Or you can use a time tool. So another tool that like an MCP server or a function call that it can use, but that slows down the process as well. So just step one. It's all about formatting the data and getting it into the right kind of structure that the LLM can interpret well. So brings us to the next question, like how do we want to present that data to the LLM? Well, you can start like I did with just raw JSON. This can work. It's kind of heavy on tokens. The models can miss relatively large anomalies while focusing on small ones. Let's say you have a time series graph where you got to have two peaks. One of them, is an 80% jump. One is a 20% jump. What I see quite often is it focuses on the first ones it comes to and kind of ignores the other. Dug into a lot of research here and found there's quite a bit of emerging research on using image representations of these type charts, like literally giving it an image of the chart instead of the raw data to improve those results. That's something we've dug into. It does work, but it's not the silver bullet. Another is more data pre-processing. So doing things like computing, max, mins, averages, that kind of thing, and also like matrix profiles as well, if you're familiar with that. More or less a kind of what is the shape of the graph along the way, and like are there like specific anomalies to look into. I say like I don't have great quantitative results here. Like this one, this is the one you should always use. What I have found is with the raw JSON, the larger it gets, the worse it gets. Maybe not surprising, and that's where like visual charts can start to take over. I have done some analysis here where I have like say raw JSON versus visual charts versus just some like summary data, and depending on the data in different scenarios, one of them will perform better than the other. Generally, the visual charts, like a simple time series graph, will perform quite well. In order to kind of set this up and test these different scenarios, this is something that we hooked up, you say at the top line here, different AI agents or desktops or Claude Code, whatever, going through the Mux MCP server, and a little test proxy server here that can make calls through to the Mux API and generate things like these simple charts here and return images directly back to the LLM, or things like like I mentioned earlier, the matrix profile of that. And been able to play with different versions of that. Again, the simple answer is none of them are the silver bullet, but for specific use cases, particularly the larger that the time series becomes, the more accurate and quicker just giving it the image becomes. The best is to give it all three, but then you're starting to pay more costs and slow down. Another challenge is it can tend to lie. In one scenario, I was happily asking this agent questions. What's going wrong with the streaming today? Tell me, build me a rebuffering report. It was giving me like reasonable answers that seemed legitimate, and it was kind of happily following the agent's lead. I started questioning the data. This doesn't look, something here is not right. Dug under, like what API calls is this actually making? Turns out the entire API integration had been broken and it was just lying about the entire data set. So you can ask it nicely here, honestly. It's unreasonably effective to just say, please don't make up data as every part of every prompt. I know that sounds silly, but it really does work. Another piece is here, as we start to build these layers, like kind of data gathering at the bottom, and you can build agents on top of it for reasoning, maybe more intelligence analysis on top. We're looking for anomalies. You start to get this large matrix of kind of complexity. When you're interpreting data at one level, give it a confidence score. Be able to say, I've interpreted this data. I'm this confident. This is why, and carry that reasoning along with that data all the way through this chain. This becomes a real application engineering and data engineering problem, but it really has improved our results quite a bit. And that kind of brings me to context engineering. And then this is where all of this, this is a buzzword now. We went from prompt engineering to context engineering. But context engineering really does seem to be the kind of holy grail here with building agents, particularly these more complex agents that are all working together. Again, back to this orchestration problem, understanding the scope, creating the plans, navigating the data. It really is all about building these pieces of data that flow through the system and can provide context on what one piece has already done. On performance considerations, again, I don't know why this is so hard to read on this screen, but being able to parallelize the processing of some of this data really means writing code and they're not just relying on a high-level LLM to expect it to solve all of your problems. This is the big takeaway I kind of have here is this is we've traded off maybe one complex engineering task for another. Those LLMs are really, really powerful at understanding and navigating, branching throughout this data, but now we're writing really complex code again. Things like caching your summaries, caching the data as you go along, being able to vectorize or embed that data and pull out the right pieces of data that you've previously looked up is also really important to performance. And some of these scenarios I'll show in a minute, like trying to build a report for maybe say a weekly summary can take, in a naive sense, 2 to 3 hours to run and cost $10 of LLM time. Again, these agent building kind of considerations, I think, one, investing early in evaluation frameworks. I think prompt engineering whack-a-mole is the worst evil that anybody's having to work through right now. So if you're not familiar with these eval frameworks, it's being able to say, here's a set of data in, here's my expected output, and now I can kind of engineer these prompts and even have the AI iterate on the prompts itself. Compartmentalizing the agents for specialized tasks is really important as well. And then finally, those memory management frameworks, aka context engineering, are coming a really long way. This is an example with a framework called Mastra, where you can now, it can help you manage, here's the last messages that we've processed. Here's how I search through other messages that were processed by my agent or other kind of parallel agents and really manage all that. But again, the complexity is really starting to rack up here. So what are we trying to target? What is the use cases for all of this at the end of the day? This is one of my favorite quotes here in all of the documentation for agent frameworks right now. Is that around you're doing these evals and building these agents, this is an emerging science. Anyone that claims that they know exactly what they're doing, you can kind of ignore them. So I don't know what that says about my talk today, but take all this with a grain of salt. But what we're trying to achieve here, things like operational summaries. This is where we're starting to actually see the good results come out of this. At a high level, I can say, build me a streaming report for the last 30 days for EU operations. Out of that, we can get some really detailed kind of executive summaries. These are starting to become handy. The more we're iterating on this, the accuracy is really going up. Incident response is another obvious use case for this. There's an alert that's going off, maybe from a piece of infrastructure, maybe you've something you want to dig into more from that high-level executive summary. And be able to integrate with other systems. This is some Mux data charts here. We have this annotation tool where when we hook in the annotation tool as well through the MCP server, this agent can go in and tag that in the actual dashboard data and correlate it back to an email summary. Here's what we think went wrong with with this playback failure spike. Down here on the left, the reoccurrence watch. This was one of the first real light bulb moments that we had. And a lot of this we're going through these incident reports, checking it for accuracy, and then this popped up. Hey, did you know that this exact same spike happened 3 weeks ago? Had no idea, right? We're starting to see those glimpses of this where if we can get this on the rails and super reliable, you can see the value here. On this as well, though, almost every single time is asking for more data. In particular, this is not including the CDN logs. This is our client-side QoE data. Every report says, you know what, I could do a lot more if you just gave me the CDN log data too. So that's kind of a next step here. How do we navigate not just one data set, but multiple data sets with these agents? And then finally, a kind of surprise use case that came out of this is data quality. So, there's a lot of different versions of this. Like if you're working in a larger organization where maybe one team's rolling out a new player version, maybe they break that player version, maybe they break some of the tagging in the player version. We can surface that. We can surface that one platform's like labeling iOS. Maybe the one's labeling it with capital letters, one with lowercase letters, and find that kind of stuff operationally as it's rolling out. So what's next? In the near term, really enhanced MCP context. So what the MCP server is feeding back to the agents around how to use this data and navigate it is one big addition to make. More MCP like meta tools. Like today it's just wrapping our API, but being able to ask in like natural language, show me the rebuffering report from yesterday and have some extra kind of agentic flows in there are really important as well. Long term, we really want to see this be like the agent that lives directly in the product that's helping you to navigate these like operational challenges. And then finally, let's come to Demuxed. I don't know why the top's cut off there. Phil's going to be very mad at me for the way that this formatting came out. But Demuxed is our the conference that we help organize. Traditionally, this has been in San Francisco for the past 10 years, but this year it will be moving across the pond to London. It will be, October 29th and 30th. I appreciate all the support from the Memento folks and the kind words they said earlier. If you're interested at all, please buy tickets and also submit your talks. Talk submissions are due tomorrow, I think. So not a lot of time, but it doesn't have to be, a full, fully fleshed out idea, but just if you have any ideas, get it submitted so we can start working through them. That's my time. Thank you.